We want to turn our attention now to graphs of parabolas, something that we started previously. We want to continue now and look at the graphs of some more complicated looking parabolas. What we're going to do first, though, is graph some using just a table. Here's our first example. I want to graph y equals x squared minus 4, and I've started the table over here. Here's the values of x I want to substitute in. I'm going to substitute them into my equation, y equals x squared minus 4, and that will give me my corresponding values of y. So when x is -3, y is equal to -3 quantity squared minus 4, which is 9 minus 4, which will be 5. When y is equal to -2, I have y equal -2 quantity squared minus 4. So that's -2 squared is 4, subtract 4 is 0. When x is -1, y is equal to -1 quantity squared minus 4. That'll be 1, subtract 4, which will be -3. Y is equal to 0 squared minus 4, which will be -4. And when y is 1, when x is 1, I have y equal 1 squared minus 4, which is -3. When x is 2, y is equal to 2 squared minus 4, 4 minus 4, which is 0. And finally, when x is equal to 3, I have 3 squared minus 4, that's 9 minus 4, which is 5. So I use my table here simply to get me some ordered pairs. -3, 5, -2, 0, -1, -3, so on and so forth. Now you can see my values of y start here at 5, drop down to 0, to -3, -4, back up to -3, up to 0, and then up to 5. And that's what's going to give me that parabolic shape when I graph these ordered pairs. Let's do that. So I want to graph x equal -3, y equal 5. So I'll go back 3, 1, 2, 3, and up 5, 1, 2, 3, 4, 5. So there's my point, x equal -3, y equal 5. Next I have -2, y equals 0. So x is -2, y is 0. That's this point. When x is -1, y is -3. So I'll go back 1 and then down 1, 2, 3. And when x is 0, y is -4. So when I'm on the y-axis, x is 0 and y is -4. And then it comes back up to x equal 1, y equal -3, x equal 2, y equals 0, and x equal 3, y equal 5. So you can see I get this shape, which I recognize as the shape of a parabola. I'll connect these with a nice smooth curve, which is not easy for me to do with this pen, but you get the idea. There is the graph of y equals x squared minus 4. Now, this graph looks like the graph of y equal x squared, just moved down 4 units. My original graph of y equal x squared would look like this. This has exactly that same shape. That is, from the vertex, if I go over 1 in either direction and up 1, I come to the graph. From the vertex, if I go over 2, I have to go up 4, I'll get to the graph. And from the vertex, if I go over 3 and up 9, I'll get to the graph. That parabola that has that shape is the shape of y equals x squared. This looks just like that. It's just been moved down 4 units. So this point right here, this lowest point on the parabola, is called the vertex of the parabola, and I can see that the vertex occurs at 0, -4. So that -4 has something to do with that vertex being at that point. Let's graph our next one. Y equals x plus 2 quantity squared. Here's an abbreviated table I'm going to use. I'll substitute in -3 for x. -3 plus 2 is -1. Quantity squared is 1. I'll substitute in -2 for x. -2 plus 2 is 0. Squared is still 0. Substitute in -1. -1 plus 2 is 1. Squared is 1. Put in 0. 0 plus 2 is 2. Squared is 4. Substitute in 1. 1 plus 2 is 3. Squared is 9. Put in 2. 2 plus 2 is 4. Squared is 16. And I'll put in 3. 3 plus 2 is 5. Squared is 25. So these are a little off the graph. So let's see. I have at 1, it goes down to 0, then back up to 1, to 4, to 9, 16, and 25. Let's go back in the other direction from -3 and substitute in the number -4 for x. -4 plus 2 is -2. Quantity squared is 4. And then I'll substitute in -5. -5 plus 2 is -3. Quantity squared is 9. So let's graph some of these ordered pairs. Negative 3, 1. So I'll go back 3 and up 1. Get this point right here. Negative 2, 0. So I'll go back 2 and I get 0. Negative 1, 1. So I'll go back 1 and up 1. I get this point. 0, 4. So x is 0, y is 1, 2, 3, 4. And x is 1, y is 9. When x is 1, y is 4, 5, 6, 7, 8, 9. So I get this point. So you can see it looks like I have a parabola that comes down like this, hits this lowest point, and then turns and goes back up. I won't graph these because I don't have enough room on this coordinate system. Let's go to x equal negative 4, y equal 4. X equal negative 1, 2, 3, 4. Y is equal to positive 1, 2, 3, 4. So I get that point. Same height as this point. When x is negative 5, y is 9. So 1, 2, 3, 4, 5. Y is equal to 4, 5, 6, 7, 8, 9. So you can see, again, I get this same shape. That is the same shape as y equal x squared. But this time, the graph is moved back 2 from the origin. So when this is x plus 2 in parentheses squared, the graph moves back 2 from the origin. In my first example here, when it was y equal x squared minus 4, that as I squared x, then subtracted 4, it moved the graph, the vertex of the graph from the origin down 4. When I do my squaring after I've added or subtracted a number to x, it'll move that graph back 2 when I have a plus 2 right here. So I can expect if I had a minus 2 right here, that it would move the graph forward 2 units.